Okay, so let me quickly share my screen. Is my screen visible?
Yeah.
Okay, good. So let me first create a directory very quickly for your batch. Information September 23. Okay, so is there anyone who is joining today for the first time? I believe no, right? Okay, so let's get started. So welcome to this course where we will be learning automation of infrastructure using different tools and technologies such as Terraform, Python, Ansible, Packer, and we will also include Kubernetes. Okay, so let me just quickly open the diagram if someone is joining for the first time for them. So we will have two major projects and multiple minor projects as part of our course. So this is our first project where we will be deploying three-tier architecture into AWS cloud. So three-tier architecture means it will have UI, application server, and one RDS server, right? So achieving this particular architecture, we will have different components altogether like VPC, subnets, then load balancer, and other supporting components like we will be writing Lambda in Python language and making use of S3 for Artifactory as Artifactory auto scaling group for scale in and scale out our application servers, right? So these all we will be doing, and this is the tech stack for our first project. Okay, so Terraform, Ansible, Packer, Python, Golang, then VS Code as IDE, GitHub, and GitHub Actions for CI/CD pipeline. Okay, so very quick overview as we already discussed a lot about it in our demo sessions previously. So you can always watch those videos if you want to get it a great detailed information, detailed session on this. So you can always watch the recorded videos. Okay, so let's coming back to our today's agenda. So today we will start Terraform. Okay, so for this purpose, first of all, as we want to work with Terraform, we would need to install Terraform on our system, right? So you can download the Terraform very easily. Okay, so you need to go to this particular page and let me Slack it as well. Okay, it's batch 65, right? Yeah. So this particular link you can open after the class, and based on operating system which you are using, you can select from here. And if it is a AMD 64, uh, you have processing, then you can processor of AMD 64 you have, right? Then you can download this. If you have 86, like it is for Intel and this is for AMD one. Yes, you can download this, and once it is downloaded, okay, so you can go into the folder, so into your download folder. Just a second, please. Okay, so inside your downloads, you can see that on the top, this particular compressed zip file is coming. So open it and you will get Terraform application. Okay, so it is downloaded as a binary. So what you need to do, you can move it into some other folder. If you have the Windows 10, so there would be a directory named binaries, and inside that you can move it like I have done. Okay, if you do not have this and if you want to install, you store it at somewhere else, like into program files or something. Okay, so what you can do, like if you are putting it into your program file, you can go to your environment variables. Yeah. Go to your environment variables, click on environment variables, go to path, click on edit, and here click new and copy the path from here, right? So suppose your Terraform you have installed here. So copy this thing and put it here. Okay. And then do the OK, and apply, and your environment variable will be set. Okay. Why I am saying to go into binary is because this particular path is already set into environment variable. So if you are moving something into this particular directory, then its path is already available. So you will be able to, you do not need to set explicitly the environment variable. Okay. Why do we need to set the path? So if somebody has that curious to know, if somebody is curious to know, so that if you are not setting up the path, then you will always have to go to the directory where your Terraform is installed, and from there you will have to run the different commands, right? But if you set up the path, then you can run this Terraform command, Terraform related commands from anywhere. Okay, anywhere in your system, from any path, any location. So for that purpose we need to set up the path. Okay, so and once you have done this, all the things, environment variable setup, and you can check with Terraform-version command if it is installed correctly. If it is giving the output, that means it is installed correctly. Okay, so this you need to do. And another thing is you need to install the VS Code. Okay, so VS Code install. And you can go to this particular link. Okay, let me share it into the Slack. Okay, and based on your operating system, if you have Mac, you can click on this link. If you have Windows, you can click on this link. I already have VS Code installed. So, however, it is very easy. You can click on this, it will be downloaded. And then again, you have to click on the downloaded file in your downloads folder. And you just need to do like any application which you like, this setup application setup will be downloaded. You will have to double click and do the next, and you are good to go. Okay, this is how you can do it. So this is about the prerequisite while starting. There are multiple prerequisites which will be coming on the way. Okay, but for now this is sufficient, and we can go ahead with our course. Okay. So let's discuss the first topic in the Terraform, which is what is Terraform, right? So we discussed it in great detail in our demo session. If anyone has any doubt from the Terraform, then I will take it once again, else we would move ahead. Okay, so is there anyone who is not aware of what is Terraform? Can raise your hand. Then I will explain, else I will go ahead.
Yeah, go ahead, guys. Those who have not joined, those who are not aware of what is infrastructure as a code, you should raise your hand now so that we can go step by step and you are not missed out. So Murli, you can unmute and what is your question? Okay, so are you all joined today? Murli, where is you didn't join last 2 days? Last, like the demonstration, like last 1 day, right? Monday. Today's Tuesday
No,
in
we
India.
had no. It's
This
Wednesday. Yeah.
Okay. Yeah. So last 2 days we had, right, demo classes. Correct. Okay. Maybe there are 3 persons. Maybe you can quickly just invest 2 minutes or 5 minutes with what exactly infrastructure as code is, and maybe then we can jump into our local setup.
Sure. Okay, guys. So why do we need infrastructure as a code, right? When you are learning any cloud platform like AWS or Azure, you just go ahead and create the resources manually, right? If you need to create the EC2 instances, so you go ahead and launch the instance manually. But in real time, there could be multiple environments, right? And multiple accounts that you would be managing. Okay, and there will be not like the single resource only. Okay, so suppose if you have different life cycles, so if you will have different cloud accounts. Okay, so for each life cycle, like for dev one, for QA you will have one, right? And then for prod you will have one, right? And in these all there would be multiple resources. It is not like just only you will have to create the EC2 instance, but it will have VPC, it will have uh, different networking components like subnets, route table, network gateway, internet gateway, then load balancers, auto scaling groups, some lambdas could be there. Okay, and RDS, right? So creating one resource in one account is very easy, but if you have to create these multiple resources in multiple accounts and you need to manage them, it is a list number of resources which I have mentioned over here, but it could be more than this. So if you have to create these resources in all of the accounts, then it will be a bit challenging for you to do it manually. Okay, and again, not only the creation, then if you need to do some modification into the resources, okay, so then doing it manually is again a bit pain, right? And suppose if you need to if you need to if you need to delete these resources in some of the accounts, some of the life cycles, so there would be dependencies between the resources, so doing it manually also again that is also a challenging task. So for that purpose, we should not, in the real time, you will not be doing anything manually. You will not be creating these resources manually into your organization. So for that purpose, you will have to use some automation tools where you will declare what all resources you need to create, and or what resources you need to delete, and that could be done with the help of automation, and that automation is called as infrastructure as a code. Okay, and there are multiple tools in the market for infrastructure as a code. So Terraform is one of those, and Terraform is most powerful tool in that segment because it is cloud agnostic. Cloud agnostic means just a second, let's serve it to some other place. It is cloud agnostic. Cloud agnostic, which means if you are learning Terraform, you can make use of it at multiple places, like not only limited to AWS, but you can make use of it in Azure, GCP, OCI, and other places as well. Okay. So this is a quick overview of why do we need infrastructure as a code. We have discussed it in a lot detailed way. You can go ahead and watch the video in our YouTube channel, or you can get the recorded session link as well, okay, for our previous demo classes. Okay, so this is about it. Yeah, so video link will be shared in the chat for the last 2 days. Okay, so now coming back to our today's discussion. So we have discussed about how can you set up your lab for our first topic, which is Terraform. Now we will be looking into different components of it. How can we configure? How can we make use of a particular provider? So let's create our first file. So how can you create uh, how do we structure our Terraform code? Okay, so first you need to create a directory. Okay, and then inside this you can create different files. And I am creating my first file, which is version.tf. Okay, so what is .tf? So the Terraform files, whatever you will create, it will have an extension .tf. Okay, and version, this is name, it could be anything, but to make it meaningful so that anyone can understand by the name of the file that okay, what kind of information this particular file contains. So for that purpose you need to define a meaningful name. Okay, suppose if you are writing, like we will be writing the automation, like code configuration for VPC components like VPC, subnets, availability zone, and all. So those are networking components. So we will be creating a file like network.tf, right? So this kind of thing we need to maintain so that our code is readable, because a number of contributors could be there in a team of Terraform developers who would be writing a particular piece of code. So if somebody wants to take a look into your source code, or if someone is reviewing your code, so at that time it will be easy for him to follow, right? So let's go to our first file, version.tf, and here we will be writing our first resource block, which is called as Terraform. Okay, so first block which you will be writing is Terraform block. Why? So here you will define the versions and all. Okay, so whatever is the Terraform version you are using, so that you need to define here. Okay, and whatever the providers version we will be using, that also we need to define here. Okay, so let's go ahead and define it. So generally, whatever is the Terraform version we are using in our system, so that we define, because our code will be executed with this version only. So what version I am using currently? So version 1.4.6. Okay, so you need to define here the required version. So how would we know like what argument we need to pass out for this purpose? Okay, so let's go to Chrome browser or any browser which you have, and Terraform version. Simply write this. Okay, so Terraform settings block it is called as. And how would you write? So this is the block. This is how you can write. And there would be some examples of it as well. So required providers, and here you can pass the providers. And one more field is there, which is not given in this example. And that field is, this is required providers version. I will be coming to provider, but first we need to configure our Terraform versions. Okay, and what is the advantage of configuring? However, it is not mandatory field, but required version you need to pass. Okay, and I am using version 1.4.6. So I will be passing 1.4.6. Okay, why do we need to pass this? Because there are multiple versions of Terraform available. Okay, so if you could Terraform versions. Okay. So you can see that there are multiple versions, like currently 1.60 in beta, then alpha 1.56, 1.50, and I am on this 1.4.6, right? So version you need to define here, declare here that you are writing your Terraform configuration with this particular version, because it's possible that on the latest version 1.56 there would be some upgrades or patches would be implemented, right? So that will not work if someone is having Terraform version 1.56 on their system. Okay, so what actually is the use of Terraform? So let me quickly give you. So like suppose if you are writing a code for your Terraform, so this will be consumed by someone, right? You have write the Terraform configuration, like you can create the VPC. Okay, you can create the VPC. You have defined the resource for VPC. So end user, that could be your client, that could be your customer, that could be your different team in your company, like application team. So they will be consuming your Terraform configuration file for creating the resources into cloud. Okay. So suppose if some team is using Terraform version on their system, they have got the code somehow from the source code repository, they have cloned your code. Okay. Like this is your suppose GitHub repo where you have hosted this particular code related to VPC. You have hosted into some GitHub repo. Okay, and that link is shared to the different teams who will be making use of this VPC Terraform code. Okay, for creating the VPC into the cloud infrastructure. Yes. And suppose if someone is using on their local system also, there will be Terraform installed to make use of this code. So suppose if someone is using 1.56, someone is using 1.39, suppose hypothetically there is a version 1.39 and someone is using 1.46. Okay, so you have written code with the help of this particular version, and if there is a mismatch, like someone is on upgraded version, someone is on downgraded version, and someone is on the same version, so maybe possible some functionality or feature which you are using in your Terraform configuration with this particular version would not be available in the 1.39, and some particular features or functionality is depreciated in 1.56. So it will not work, right? It will break, your code will break, your configuration will break. So for that purpose, everyone should have on the same version. So for that purpose, we define here that, okay, this is the version constraint on which this particular Terraform configuration, whatever we will be writing, is written, and we need to make use of this version only. Okay, so suppose in this case, I am using 1.56, for example, and on my system, it is 1.46. So this time only it will give you an error that, okay, this particular version is not available on your system. Okay, yeah. So this command does not support Terraform version 1.46. So initially, if someone is getting this error, that means, okay, either you have to downgrade their version to match this particular version, which is defined here, so that the code written, configuration written inside this particular Terraform resource will be executed, or you will have to upgrade, like whatever version he is, either he will have to upgrade or downgrade. So it is initially only will be made sure that at the same version everyone is, and nobody would be, if you are not defining it, then nobody would be knowing like which version it is supported, and it will, the code will break, right? So they will not able to provision the resource, and that is not a good practice, right? You are creating everything and then giving to the end user, and they are not able to consume it. So that is a failure of your product. So you need to make sure that you are providing the required version constraint. Okay, so there are okay, so this is about
So
required
one, before
version.
you
Yeah,
proceed, Gaurav,
yeah.
anyone who didn't understand this, raise your hand. This is very, very important. Here, because this is a beginning of the class, just wanted to inform you all. Doing projects, doing a lot of things, it will help in clearing a lot of concept. But then this concept which he is explaining now, okay, is the real thing. Okay, that okay, when you upgrade the version, this small thing, it matters a lot for your interview, and you can create a story out of it, right? That this particular parameter was not set up in your environment, and because of that you face this many issues when you join the company, and then you fix the issue by enabling this or by standardizing this particular setting. So, and since then this is kind of a it's like good. So something they might ask you, okay, what kind of challenges you have faced in your current environment. So at that time you can say all these things. So not just this particular story, you can tell other stories also, because there are a lot of stories which we are going to share with you. And believe us, that is the reason you are actually paying for the course. That is the reason you are actually investing a import, like such a critical time of yours, like 1 hour every day, right? Where a motivational like Gaurav is there, who is explaining you, motivating you on each and every angle, and then you are actually taking that lecture, right? And creating your own own CV, on resume, which you will be applying for a job. So so don't forget that these points are very, very important. If you miss it, see the video, write it down, write your story, maybe ask in Slack channel what can be the story for this particular thing. Discuss between each other, and that will create a good story for all of you. Okay. um And that's it, Gaurav. Sorry for interrupting. You can proceed.
No, it's all right. So yes, guys, do you have any question? Like I'm getting one question is in chat from Baswaraj. In the place of value, we put asterisk. It is possible. No, it's not possible. There are version constraints which you can use. I will discuss it about in few minutes. Okay. So, is there any question, any doubt, any confusion in this particular diagram? Is the version is not backward compatible? See, backward compatibilities, yeah, that is backward compatible.
So they say that it is backward compatible, but then believe me, I have done recently an upgrade, Terraform version
Yes,
upgrade, and it breaks like anything. All of our codes are breaking, and it's like it was we thought that it will be a 1 month project. Now it became 3 months, and it's a very big code which we have to do, and that same thing, this particular piece of code is being shared by a lot of different teams, and
yes,
all the teams are, if we do something upgrade, other teams are also impacted, and it's a big impact. Okay, business impact, because if you do some changes, your auto scaling groups will not be working, your servers will not be spinning up. Okay, because that will be breaking. Okay, and then if your servers are not spinning up, your application will be down, and then it will be a big mess. Okay, so believe me, it's like very important. Okay, and we this particular small thing, okay, it's very important for you to give these things and upgrade it, test it, and understand whatever we are discussing now, each and every point. Okay.
So, Rahul, is it a bug or because
No, it's not a bug. It's not a bug. See, uh, Terraform will deprecate something, and that deprecate, when they deprecate, it will give warning. Because of that, maybe a list is there, a tuple is there, so something will break. Okay, so maybe when you are suppose using a data source, which will be explained to you by Gaurav very soon. So a data source was giving previously a string, now it is giving a list, and that breaks. Okay, so a lot of things are there which you have to understand. Okay, which they say it's backward compatibility, but in real life I'm seeing it's not. Okay, and believe me or not, this is how we have to deal with it. Okay, so yeah, it's not a bug. If you raise, you can't, it's an open source anyway, you can't even, you can just raise an issue, but they will say it's not a bug. Okay.
Okay, thank you.
Yeah.
okay. Thank you, Rahul. Okay, so as far as this version is concerned, so it is in the format of major, then the second portion is minor, and the third portion is patch. Okay, so as far as backward compatibility is concerned, Ravish, so this major minor patch, if you are doing the patch, this patch will be backward compatible with this minor version. Okay, but if you are changing the minor version to something else, like suppose if you are 1.5 and then you are talking about 1.3, so these are all different versions altogether. Okay, so this patch can be backward compatible to the minor, but the two different minor versions or two different major version, if you are all together using, so that are completely different versions. Okay, you can have at the patch level the backward compatibility possible, but not at the major or minor level. Okay, this is how they define. Okay, so this is about required version. So you can either give it completely like 1.5.6, or you can make use of version constraints. Okay, version constraints in Terraform. Okay, so there are multiple ways you can define the versions, that it should be equals to a particular exact version number. So for that purpose, you can make use of this. If you want to exclude a particular version number, then you can make use of this. And if you want to make use of something like greater than, equals to, or less than, so if those kind of scenario, then you can go with this. But generally in real time, this is the most widely used, and mostly this particular constraint is used. Okay, so suppose in our case, if we want to make use of, like in my case, the Terraform version which I have is Terraform version is 1.4.6. So in this case, I can write something like tilde greater than 1.4. Yes. So it will tilde greater than 1.4. It means that this will be static and this 4 will be variable, like rightmost value can be changing. Okay, so 1.4 suppose if I am taking 1.4.6, then this 6 can be changing. Okay, it can be anything, it can be 7, it can be 8, but these two will be static, it will not be changing. Okay, it will be constant. Okay, and if I am doing 1.4, so it will be using 1 will be the constant and 4 can be changing from 4 to 5 to 6, that can be done. Okay, so rightmost value will be changing. So this is the most popular way of using the version constraints, and in this particular, rightmost value is change. Okay, so suppose if I am doing the Terraform version now, Terraform init now, so it will be initialized because I have the Terraform version available on my system, which is 1.4.6. Okay, fine. So this is about the required version constraint, why it is important. We have discussed it in great detail. Okay, let's go ahead and now we will be configuring our providers. Okay, so what is provider? Okay, so there is multiple providers. If you have attended the last session, we discussed about it. Excuse me. So there are multiple providers available. So if you go to providers, there are different providers: AWS, Azure, GCP, Kubernetes, and all. We are currently into AWS providers. So if you will click on this, you can see that this is the provider page of AWS. Okay. And why do we need to define here? We need to define here, right? We need to define here through the, how can we use the provider? So this block we need to define. Why do we need to define? That way, because Terraform supports multiple providers. So this way it will understand, the Terraform will understand that which particular provider you want to use. So suppose if you want to make use of this AWS provider, so you will provide the source and the version. So with this, your Terraform will understand that, okay, I need to use the AWS provider of this particular version. Okay, so what is provider? So provider is nothing but, if you would check the source code, so it is a Go library, okay, which is running in the backend. Okay, and this is making use of Go SDK of AWS. Okay, so if you are interested, you know the Go, you can look into this all, right? And yes, so you can look into this and check what it actually doing. Okay, so Golang is in the Terraform. Terraform is also written in Go, and all the provider plugins are also written in Go only. Okay, so these are the source code files for the like Terraform provider, Go provider, AWS provider. And here you can see that some infrastructure which it is creating in the backend for this provider, that is also written here. And this is examples is there, then internal is there. Right there. And yes, provider.go, provider account, provider test.go, everything is written. Okay, it is internally making use of multiple Go packages. You can see that AWS SDK Go version 2 it is making use of. Okay, So this is the Terraform Providers source code. What actually Terraform Providers do, okay, that we will be seeing. Before that, let me configure this particular thing, provider, and then we will get into that. So you can simply copy from here, required providers, and you can put it here. Okay, so it can be anything, it can be any name, but it is good practice for the readability purpose, whatever provider you are using. If you are giving the name same as of that, so it is good practice for readability, but it can be anything. It can be Rahul, it can be Ravish, okay? But for readability purpose, it is good to have the name AWS, okay? And another thing is, you are providing here source and this particular path. What is this path? Okay, so when you provide this path, which that simply means your Terraform will go to registry.terraform.io. Okay, you do not have to explicitly define it here. That is internally calculated by the Terraform, and go to this path inside providers. Okay, inside providers, go to this path, HashiCorp AWS. Okay, and at this location, this particular provider is available. So if suppose if you need to make use of Azure, so you will, what you will provide? You will provide HashiCorp/Azure in your source path. Rest of the things will be calculated by Terraform itself. And you need to use some version, right? So what version you want to use of this particular provider, so that you can select. So there are multiple versions are available, and it is like these providers are like patching and upgrades are being done very frequently. So you can see that 5 days ago there was a release, 12 days ago there was a release. Okay, so I would recommend not to go with the latest version, because that could have some bugs and that need to be fixed, right? So if you want a stable version, so either you can go the previous one or previous -1 version. Okay, so like 5.131, 5.140. So let's select this 5.131. Okay, 5.131, and make use of this version. Okay, so when you are defining this particular piece of configuration, what it actually do, the Terraform, is see the what is the required providers block in this, what is the source, HashiCorp AWS. Okay, so go ahead to this particular path. This is auto calculated by the Terraform internally, because this is their own written path, they know about it. Okay, then what actually you need to use, so for that purpose you will provide the path. Okay, so HashiCorp AWS. If you need Azure RM, you will give HashiCorp/Azure RM, and then the version, whatever version you want to specify, because Terraform will by default always install the latest version. If you want to make use of other version, as I told you that we should not go for the latest version, okay, because that could have some bugs and all. So that should be fixed, right? So in the production environment, it is good to go ahead with the 1 version or 2 version before of the latest version. Yeah, so this is good practice. So you are providing this version. So if you will, you are defining it, then what Terraform is doing, let's see that. Okay, so you will do Terraform init. So this is the first command, guys, which you need to run for initializing your Terraform. Okay, so let's do the Terraform init, and let's see what is happening. So it is initializing the backend. Backend we will talk about. It is not still introduced to you guys. We will discuss it in a relevant section. But for now, look into this initialize provider plugins. What it is doing, it is trying to find out HashiCorp AWS version matching this. Okay, so it is trying to find out, it is going to this particular registry into the providers, and on this path, it is trying to find out, okay, is there any provider version available with the given version over here? Yes, it is available, right? It is available 5.131. So now it is trying to install this. Okay, where it will install? In your directory, it will create a .terraform folder, and inside this, it will create the provider plugins. Okay, it will install the provider plugins. So it is nothing but instead of doing it manually, you can download it manually as well. But instead of doing it manually, Terraform is doing on behalf of you. Okay. And this is Terraform init step is doing. Okay. Initialization of your provider. So this is an executable. Okay. You can see that it is executable. And let me also show you the Terraform ls city providers ls registry.terraform.io ls cd _. So it will also install at the same path. Okay, whatever it is, ls cd aws ls cd 5.13.1. Yeah, ls. So here you have Windows AMD 64 ls. Here is your executable. Okay, let's try to see PWD, present working directory. So this is coming from my system till now. And then .terraform inside this providers, registry.terraform.io, _, AWS 5.3.1. So same path it created locally into your system as well, right? Whatever is available here. Registry.terraform.io, providers, _, AWS, and then the version number which you are using. And then it, as we are using Windows, so Windows related, it has installed, and this is the executable file. Okay, fine. So this is the particular location where it has installed the provider. What actually provider does? So like suppose, so what you have written your Terraform code, like piece of code, like for some resources like EC2 instance you want to launch into AWS. So you will be writing here some code, right? So you will write one file ec2.tf, and there we will define the configuration that how do we want to launch our instance. We will be coming to that point. Okay. But for now, think that we have created a EC2 instance configuration file. Okay. So we have created this. That's good. But how it will go ahead and create the resources in cloud? We have written, just writing the code will not help, right? We need to have some mechanism so that this particular configuration which you have written over here will be implemented to the cloud. Okay. So for that purpose, you need to have a plugin which is called as provider. Okay. Okay. So this, when you do the Terraform apply command, we will be seeing that command too. Okay. But there is a way, there is a command which will actually deploy, provision the resources into the cloud. Okay. So when you do the Terraform apply, what actually happens? When you do the Terraform apply, so this particular code, when you do the Terraform apply, so this particular code is here in your system. First, your plugin will be called this particular provider plugin. This is internally written a AWS SDK for Go. AWS SDK written in Go, as I have shown you in the source code. And that will make an API call. Let me remove this line. Maybe it will be confusing for you. Okay. So this is your provider. This is your Terraform, which you have installed Terraform binary. And when you have written the code, you are running a command Terraform apply. Terraform. So in that case, what happens? Your Terraform provider will be making an API call to your AWS or whatever cloud you are using. Okay. And this provider is written internally in Go, and it is making use of, it is written in Go, and it is making use of AWS SDK. So this particular provider will make your EC2 instance code, whatever the configuration you have written, that Terraform is also in the backend written in Go, and this will be converted into a Go code. And this provider will make an API call to this particular AWS infrastructure, AWS environment, or Azure ARM, or whatever it is. So it will make the call and provision the resource. Like you have defined here to create the EC2 instances. So that EC2 instance will be created in this particular cloud infrastructure. Okay. So explain you once more time. Okay. So this is your Terraform binary. Terraform binary. This is your provider plugin. This is your cloud. This is your configuration. Okay. So if you are running Terraform apply, so what is internally happening? So this provider will be communicating to the AWS or whatever cloud you are using. In case of AWS, it is making use of AWS SDK for Go, and it is communicating to the cloud, making an API call, and whatever resources, like you want to create a EC2 instance, so whatever you have defined, so that thing it will do for you. Okay, so it has multiple API calls can make, like if you want to create something, so post could be there. If you want to retrieve some data, then get could be there. If you want to delete something, so delete could be there, right? So those kind of API call this particular provider makes internally to the AWS cloud and do the provisioning, destroy, and everything on behalf of you. Okay. Is there any question from this?
Gaurav, so how my Terraform is verifying my AWS environment while creating?
Yes, so validation, right? That's what you want to ask. Yeah. So you will need to configure your credentials. Okay. You will need to configure your credentials that we will be discussing. Okay. How you will authenticate yourself to a particular cloud and go ahead and create the resources.
Okay.
Yes. So there are multiple ways. Like first way is like you must be aware of environment variables, right? You can set up the AWS secret key and access key in the environment variables. Then you can have credential files. Then you can have like roles also. If you are running your Terraform server into AWS cloud itself, so you can attach an instance profile to it, and that will work for you. Another way is you can have STS assume role. Yeah, so all of this we will be covering, okay, in the upcoming sessions. Okay. So this is how it internally works. So provider is the main which is responsible for internally making the calls and doing the things, okay, into your cloud provider. Okay, so this particular configuration, whatever we will be writing, it is nothing but a wrapper on top of a Golang code. Okay, so because DevOps engineers are not meant to be a developer, right? So Terraform has developed a wrapper on top of the Golang. Okay, so whatever you define here, like this is a declarative language. So whatever you define here, like for VPC, if you want to create like I want a VPC with the CIDR range of this, then these many subnets and all. So that is internally converted into a Go code. Okay, that is internally converted into Go code, and it is abstracted to you because DevOps engineer are never meant to be a developer. Okay, so this will be internally converted into Go code, and then with the help of this provider, it will be making those things, whatever, like if you have to provision something, destroy something, that it will be doing. Okay, so but we do not have to worry about the internal parts. Even you don't have understanding of these internal things, that's not a problem, because end of the day you will be writing the configuration and these things are already abstracted from you, and that will be taken care internally by the Terraform. Okay, so for understanding, like better understanding of the things, how it is happening, I have described this, but it is not as such important for you. Okay, so this is how it works. So providers plays a very important role. Okay, so you can define that here. Also you can have version constraints, like here we have did the version constraint, made use of this particular version constraint, which is changing the rightmost value. So here also you can have, like, if you want major version to be 5, but minor version could be changing from 5.13 to 5.16. Okay, so you can define it in this way. Okay, so this is how you can define it. Other version constraints are also there, but I do not want to waste time on that. It is quite easily understandable everywhere this particular notation is being used, and generally in real time you will definitely be using this one. Okay, so that's why I have stressed more on this. Okay. So yeah, we need to learn what is relevant. We do not have to waste time on each and every concept, else it would be theoretical session, like a college classroom like scenario we will be into, right? And as far as if you want to explore these, I have already shared the document link into Slack, and you can look into those. And guys, I would highly recommend to go ahead and see the Terraform's documentation. It is very good. It is very briefly explained. So you can always go ahead and see this document. Okay. And you can easily follow whatever is your requirement. Fine. So guys, it is already 8:56. We have 5 minutes. If you guys have any question from today's session, any question of any kind, it can be silly, it can be very logical or very analytical, you can ask. Okay.
Hi, Gaurav. This is
Yes,
Ranjit.
Ranjit.
Gaurav, as you have explained, example, in my company, I'm using AWS, and a customer or client requested to provide a code or to move it to the cloud. So they were using Azure. Example, I'm using AWS and my customer is using Azure. I've written a code. But how can I change it from AWS to Azure? Because I'm using AWS on my company. I've written the code, I've performed it, everything is fine. Now I need to provide this to the customer. And they're using Azure or GCP or whatever it is. So how are we going to change it? Or is it compatible with both the clouds or?
No, it is not possible, because for AWS there are different kind of resources, like AWS make use of VPC, Azure makes use of VNet, right? So
Yes.
they are different. Even the provider is different altogether. So different providers works in different ways. So you will have to write the code for Azure from scratch. You cannot convert from one to another. Okay.
Yeah, thank you, Gaurav.
However, most of the concept of Terraform, as far as concept is concerned, that Terraform level concept will be same. Okay, like there are multiple things like meta argument, there are dynamic block, there are for loop and all in Terraform. So that will be same in all the cloud providers, but the resource level things will be changing from cloud to cloud. Okay, right? Manually also, if you have learned AWS, you know the things like how the cloud architecture is. There is a VPC, there is subnet, but in Azure that will be called with some other name, right? So you will have a fair understanding, but you will have to know the resources in that particular cloud provider also. Then you will be able to write the code, and you cannot convert from AWS to Azure, because these are two different providers altogether. Okay, fine.
Yeah, Gaurav.
What are the opportunities for Terraform? So many opportunities. You cannot find any job of DevOps, SRE, or CloudOps, or platform engineer without Terraform. Okay. If you think I am claiming false, so you can go ahead and check on any job portal like LinkedIn, Naukri, Indeed, Monster, whatever. You will find for the DevOps role there would be definitely Terraform.
Hey, this is Syed. Uh,
Hey,
for
Sayed.
example, yeah. For example, if you we learn Terraform, right? That infrastructure as a code, right? And you told that when we write infrastructure as a code to build, for example, EC2 instance on Amazon, that code not work for GCP or Azure. So I mean, is there any other language that you can write one code and it run in any other, or Terraform is the you can slightly change. For example, VPC, remove the VCP and put the VNet there, right?
Yes.
And you can run it for other Azure.
Yeah. So most of the block structure like Terraform, required version, required providers, here you can make is your block structure will remain same. If you need to create some resources, so resource block which is provided by the Terraform will remain same. But inside this, whatever the resource you need to
I
define,
got you.
with that will have the different name and different arguments. Like in VPC, we call it CIDR, right? In VNet,
Correct.
it would be some other term. So that you would need to change. But higher level, the resource, which is the concept which is coming from Terraform, that will remain same, right?
Okay. So what you will cover in this course? Like you will go with the AWS, Terraform, or you go with the Azure or
Azure. No, sorry, AWS. Yeah.
only AWS and Terraform,
Yes.
right?
Not
So
only
after that,
AWS Terraform, there are multiple tools as well. Ansible, Packer, then Python would be there. Then Kubernetes also we have. Okay.
so you will create a Docker containers and manage with the Kubernetes and right?
Yes, we will be containerizing, orchestrating with the Kubernetes.
Okay. And Ansible you will use for the configuration.
Yes, exactly.
Okay.
So 𝐒𝐷, it is of 35 hours, the complete courses. Okay, but it
So
can
we
go
can we can write a Lambda function too within this, or what?
Yes, we can write the Lambda function. That's why we will be learning Python, and we will learn all the concepts related to Python for a DevOps engineer, and we will implementing it into a Lambda function.
So basically, this is like a DevOps kind of thing, or just Terraform?
It is DevOps, not Terraform. Terraform is the first topic which we have started today. It is the first class, like demo class is already over. We had 2 demo classes where we have discussed all the things which we will be covering.
I'm
And
sorry, I just joined it, so I don't know.
no
Yep.
worries. So this particular course, in this particular course, I just want to give you a quick review, and you can go through the recorded session of our demo. It is provided already in the chat. So in this, we will have 2 major projects. First major project will be 3-tier architecture. Like when if some user is coming and hitting some DNS, so from DNS to the database, everything we will be managing. So we will be creating a automation project. These all will be created with the help of automation, like from Route 53 to VPC, availability zone, public and private subnet pairs, load balancer, then a web server, application server. We will be managing application server through the auto scaling group. Okay, then we will have RDS, and it will be a request response model. App server will be communicating to MySQL, getting the data, okay, and putting the data, those kind of things it will be doing. And we will be using Lambda for artifacts, like if we have Java application, so when we build it, it generates a WAR file or jar file, whatever is the type of application it is. Then we need to put it into some artifactory. We cannot, it is not good practice to put the artifacts directly on the server. So we will be putting into some artifactory. That could be JFrog or and Nexus and all. But in our case, we are using S3. Okay. So in S3, we will be putting it, and every time a new build is coming, new artifact is coming, we want to update our app server with that new build, new artifact, right? So for that purpose, we will be using Lambda, which will trigger on each update of S3. Okay, so if there is a new WAR file is deployed, then this Lambda will trigger and it will internally put into app server. So that logic we will be writing into Python. So to understand this Lambda, first we need to understand the Python, because we are taking everything from zero. Like I assume that you guys do not know anything, and we are starting from zero. Like in Python, if we talk about like data structure, then the functions, then the loops concept, all will be covered, and then we will jump to this particular practical. Okay, so it is practical oriented, and we will be covering the most relevant concept of to achieve a particular project. Yeah. So
yeah, and you do all that stuff in Terraform, right? load balancer
Yes,
creating
yes, yes,
and
yes.
select the routing, what kind of routing and all
Exactly.
that.
Everything. And configuration of this, like Terraform will launch the instance, but it will not become web server until we are configuring it, right? Like we are
Correct.
not installing Apache and all.
Use Ansible for that, right?
Yes, for that purpose, we will be using Ansible, and we will be not doing it manually. We will not be running Ansible commands manually, but it will be done automated way through the GitHub action. So this will be used as the CI/CD pipeline tool, and this will be doing everything for us. Okay. Even we have Packer, which we are using for the building the images. Like in real time, nobody would be going ahead and creating the instance with the base image, which is provided by the AWS, if I talk about AWS in general. But on top of that, different type of hardening is being done, like some securities are put on, some dependencies are installed which is relevant to your use case, and then an image is generated which is being used in the real time. So to building those images, there is another tool, okay, automated tool, which is Packer.
Like
So we will
AMI,
be...
you mean AMI or
Sorry?
AMI images or different images?
Yes, AMI images, and on top of that, we will do the different hardenings based on our requirement. Yeah.
Awesome.
So, and then like if you are writing Terraform configuration, it is good idea to test it, right? Whatever code we write, we need to test it first. So there is a Grantwork is a company which provide TerraGrant is one tool of them, and another package they have which is called as TerraTest, which is used for very much used nowadays in the industry to do the automated tests on your Terraform code. So we will be learning about TerraTest also. So that internally makes use of Go. So we will be introduced to Go as well, okay, in that particular project. Okay, so this is our first project. And then we have another project. I do not have diagram for that, but I would like to quickly give you an overview. So we will be creating EKS cluster again with the help of Terraform. With the Terraform, we will create the EKS cluster. In that EKS cluster, we will do multiple projects, like we will deploy a Node.js application, integrated with MongoDB. Okay. Again, very much relevant from interview perspective and real-time perspective is monitoring of the EKS cluster. So we will be making use of Prometheus, Grafana, and Alert Manager. So these components we will be installing on the EKS cluster. Then we will show you another one, which is New Relic. Okay, so these all projects, this is one major project of EKS, and it has multiple minor projects. Okay, and this all will be done, like installation of these all we will be doing with the help of Helm. And also we will introduce you to the, like, it is not possible to cover everything in a single course. So basic components of Kubernetes, like pod, then deployment, then services, then ingress, okay, and then RBAC, then PV, PVC, and storage class. These all we will be covering as part of this course. Okay, so that part
Thank
of
you.
this course. So this is the agenda of this course. Okay.
Thank you very much.
Yeah. So if someone is interested into seeing the recorded session, so in the chat you can scroll up and see the video. YouTube link has been shared for the recorded videos. Let me put it once again. And yes, and this is link for day 2. Right, so you can go through this and watch it. Fine, guys. So I believe there is no more question, right? Yeah. Okay. So let's meet tomorrow, guys. We will continue with our Terraform journey, and we will be configuring other resources. As far as Dusani Yashwanatha, as far as Indian market is concerned, in DevOps, hiring is happening a lot. Okay. a lot of hiring is going on. You can check on LinkedIn and Naukri for the DevOps role. The market is quite good right now. Yeah, I'm not sure about other countries, but in India it is very good. Okay. Okay. Fine, guys. Thank you. Let's meet tomorrow.